because buried in lunar soil is a substance so rare on Earth, yet potentially powerful enough to unlock clean fusion energy, helium-3, and as nations prepare to return to the moon. A silent question is emerging behind closed doors in Washington, Beijing, Moscow, and New Delhi. But on the moon, it is believed to exist in significant traces across the surface spread over millions of tons of soil. Why does this matter? Because helium-3 is one of the most promising fuels for nuclear fusion reactions that could produce massive energy output, minimal radioactive waste, and no carbon emissions. In theory, just a few tons of helium-3 could power entire nations for years. And suddenly, the moon is no longer a symbol of exploration. It becomes an energy vault, a strategic resource zone, a future battlefield. To understand why helium-3 matters, we need to understand fusion. Fusion is the same process that powers the sun. When light atoms merge under extreme pressure and heat, they release enormous energy. And like fossil fuels, fusion produces no greenhouse gases. Unlike traditional nuclear fission, it produces far less long-lived radioactive waste. And helium-3 is considered one of the cleanest potential fuels for advanced fusion systems. So why the rush? Because history shows something important. Whoever controls the resource controls the future supply chain when the technology catches up. That is exactly what is happening now. The race is not just about energy, it is about future dominance. The 20th century was defined by oil. The 21st century may be defined by space energy resources. Already, major powers are reshaping their space strategies. The United States is expanding lunar return programs through NASA's Artemis missions. China is accelerating its lunar exploration roadmap with long-term crewed ambitions. Russia is re-evaluating its deep space cooperation strategies. And India is rapidly scaling its lunar and planetary missions. And this time, it is not about flags and footprints, it is about resource rights. Even though the Outer Space Treaty declares that no nation can claim sovereignty over celestial bodies, it does not clearly define resource extraction. This legal gray zone is where the future conflict is forming. Because history tells us something uncomfortable. When resources are valuable enough, laws become flexible, and extraction becomes inevitable. Imagine the moon not as a distant object, but as an industrial zone, mining robots extracting regolith, automated processing stations separating isotopes, orbital transport systems moving material toward Earth orbiting facilities. But there is a darker side, because whoever controls lunar extraction infrastructure controls the supply chain of a potential future energy monopoly, and monopolies in energy shape civilizations. The danger is not immediate war. The danger is gradual escalation. Competing lunar bases, exclusive landing zones, resource extraction safety zones, private military protection of assets, and strategic exclusion of rivals. At first, it will look like innovation. Then it will look like competition. And eventually, it will look like control. But only if access to extraterrestrial resources is managed peacefully. The key question is no longer, can we extract helium-3? The real question is, who writes the rules of extraction? Because the first entities to establish operational lunar infrastructure will not just participate in the future economy, they will define it. And once systems are built, secured, and scaled, they are extremely difficult to displace. The moon has always been a symbol of distance, of dreams, of silence. But today, it is becoming something else entirely, a resource frontier, a geopolitical chessboard, and possibly the most important strategic location in human history. The Helium-3 race has not yet been declared, but make no mistake, it has already begun. And the winners of this race will not just shape energy markets, they will shape the next century of civilization itself.